I scored a perfect 800 on the math section of my SAT, and in this video, I want to show you every single type of circle question that's going to be on your SAT. We'll go through 5 examples, starting with the easiest question and ending with a question that even my smartest students get stuck on. And be sure to watch the entire video because throughout the video, I'll be sprinkling in little tips and tricks to save even more time with the circle questions on the SAT. Okay, this first question says, in the XY plane, a circle with radius 5 has center -8, 6. Which of the following is an equation of the circle? Now this one, we're just going to be learning how the equation of a circle works. So it's actually really simple. It's just going to be x minus h, where h is the x coordinate of the center of the circle, squared, plus y minus k, where k is the y coordinate of the center of the circle, squared, equals r squared, where r is the radius of our circle. So what this means is that if we have, for example, x minus 3 squared plus y minus 4 squared, then we pull out the 3 and the 4, and those are going to be the x and y coordinates, and this is the center of our circle. Now say that this equaled 16, then we know that this equals r squared. So if we square root both of these things, then we would see that in this situation, the radius would be 4. So using this, let's look at the equations. Well, if the x coordinate of our circle is -8 and we subtract -8, then we're actually just going to want to see a +8 next to the x. So it's not going to be A and it's not going to be C. And then between B and D, we can see that actually both of the y portions have y minus 6. So that's not going to help us. So now we need to look at the radius, which they tell us it has a radius of 5. So if it's going to equal r squared, it's going to equal 5 squared, which is just 25. So our answer for this one is going to be B. Okay, now this next question is going to be a little bit harder, so let's get straight into it. It says the number of radians in a 720-degree angle can be written as a pi, where a is a constant. What is the value of a? So for this one, the concept we're going to be learning is how to convert between degrees and radians. Now, both of these things are just a way to measure an angle. So if we have an angle here, where this is our angle, and let's call it angle x, we can express this angle in both degrees over here and in radians. So the way that you can remember how to convert between them super easily is just remember that a circle has 360 degrees. So I'll write 360d, and it has 2 pi radians. So this is probably the new part for you, 2 pi radians, but it's really not that hard if you can just remember the 2 pi radians, because everyone knows that the number of degrees in a circle is 360. So if you can just remember the 2 pi radians, you'll be able to convert between them super easily. Now, how do you do this? Well, you just write 360d equals 2 pi r. And then once you have that, say that you're given, for example, up here, we have something that's in degrees. We'll write 720 degrees. So this is what we start with. And then based on which one of these things we want to convert to, we'll put that one on the top. So let me rephrase that to be a little bit more clear. If we're starting in degrees and we want to go to radians, we'll put degrees on bottom and radians on top of a fraction. So in this case, we're trying to go from degrees to radians. So radians will go on top. We'll have 2 pi radians over 360 degrees. And that works out so that the degrees cancel out on top and bottom. And now we are going to be in the units of radians. And then we just multiply these numbers and divide them as we need to. So we'll have 720 times 2 pi over 360. Now this one, you can throw it into Desmos, it'll take a second. Or you can just recognize that 720 over 360 is just 2. So we're going to have 2 times 2 pi. So it's just going to be 4 pi. And then in this case, they call that a pi. So obviously the a is going to be 4, and that's going to be our answer is just 4. Now let's say that alternatively, instead of going from degrees to radians, we wanted to go from radians to degrees. So let's say that they gave us that it's 4 pi radians, and we want to know how many degrees that is. Well, now we're going to multiply it by this same fraction, but just flip the top and bottom. So now we'll have 360 degrees over 2 pi radians. Then, of course, the 4 pi is in radians, so the radians cancel out. We'll have an answer in degrees, and we can see that the 4 pi over 2 pi would cancel out to just a 2. And then 2 times 360 is, of course, 720, which is what we started with. So that is how you convert between degrees and radians A little bit trickier, but still not too hard. Okay, now if you've been following along this far, you should be able to do this next question on your own. So I'm gonna challenge you to pause the video when we get to this next question and try it by yourself before I do it. Because ultimately that's the only way you're gonna improve is if you try the things that you learn in this video. Okay, the question says, in the XY plane above, points P, Q, R, and T lie on the circle with center O. The degree measures of angle POQ and ROT are each 30 degrees. What is the radian measure of angle QOR? So go ahead, pause the video, try this one by yourself, and then unpause it when you think you have an answer. Okay, so for this one, we have the points Q, R, P, and T. We have Q, P, R, and T with the center O. They tell us that POQ and ROT are each 30 degrees. So POQ is basically, if I were to draw it out, it would basically be this little angle right here. And we know that that's going to be 30 degrees. And then we know that ROT, which is basically this one over here, we know that that is also 30 degrees. They're asking for the radian measure of QOR. So QOR is this, this, this. So we're basically looking for this in an amount of radians. So how do we do this? Well, the first thing that you should notice is that we're starting with some angles and degrees, and we're ending up in radians. So we will have to be converting between degrees and radians. Another thing that you might notice is that we're only looking at half of the circle. So if we know that an entire circle is 360 degrees, then we know that half of a circle is only going to be 180 degrees. So that means we're going to have 30x 30, but we know that the entire thing added together is going to be 180. So we know that 180 equals 60 plus x, where x is our missing angle. So if we go ahead and solve for x, we can subtract 60 from both sides, and we'll have that x equals 120 degrees. So we know that it's degrees, but we want the answer in radians, so you have to be careful here. Now, once we know that we want 120 degrees, and we want to convert that into radians, we're going to use the trick that we learned before. So we have 120 degrees, and we're going to multiply it by either 360 degrees over 2 pi radians, or 2 pi radians over 360 degrees. Now, since we're trying to end up with radians, we're going to put the radians on top. So we want 2 pi radians over 360 degrees. Now, what does this equal? Well, we know the degrees cancel out. We're going to have radians. That's good so far. Now, 120 over 360 simplifies to 1/3. So we're going to have 1/3 times 2 pi, which is just 2/3 pi. So our answer is going to be C. Now, if you've watched the video this far, you'd definitely be interested in my free SAT prep community, SAT Masterclass. We have literally thousands of practice questions like the ones you're seeing in this video, a full 8-week course going over everything from math to grammar, and we have free live tutoring every single week with an expert SAT tutor. Now, if you're interested at all, you can join completely for free with 2 clicks by going to satmasterclass.org. Now, for this next question, it could either take you 5 minutes or 5 seconds if you know what the trick is. Okay, so the question is, the equation above defines a circle in the XY plane. What are the coordinates of the center of the circle? Okay, so now what you might say is, oh, well, this is easy. We know that it's just going to be, whatever we're subtracting from x, let's say we have x minus n squared plus y minus m squared equals r squared. Oh, well, it's just going to be n comma m. However, what you're going to notice is that this is not in this form. We have it basically factored out so that we're not in these little nice parentheses that give us the exact center of the circle. So this is actually going to be a lot harder to figure out the center. And the way that you would normally do this before we had Desmos is actually you would have to go through, complete the square, and it's a really tedious process. But by knowing that we now have Desmos, you can save several minutes just by plugging this into Desmos. So pause the video right now, go into Desmos, plug in exactly what you see here, and you'll immediately be able to see that the center of the circle is at -10, -8. And do you see how much time you save there instead of having to solve this completely by hand? It's actually insane how much Desmos can help you on the SAT. Okay, now this last question is both the hardest type of circle question that you could see and also the most common that you're going to see. And it actually takes 2 forms, so be sure that you pay attention to both because I can guarantee that some form of this type of question is going to show up on your SAT. Okay, so it says the circle above has center O, the length of arc ADC is 5 pi, and x equals 100. What is the length of arc ABC? Okay, so we have this circle. I'm going to redraw it a little bit bigger right here. So we have our center O, we have point C, point D, and point A, and then all the way over here we have point B. Now once again, the center is O, and then we have this arc right here, where this angle missing is X degrees. So they tell us that arc ADC, so that's ADC, so basically this right here, has a length of 5 pi. And then they tell us that X is 100 degrees. So let me go ahead and erase the X because we know that this is 100 degrees. Okay, then the question is, what is the length of arc ABC? So basically, what is the length of the rest of the circle minus the 5 pi? Okay, so for this is called an arc length question, and the way that you approach it is you want to set the proportion of the angle out of the entire 360 degrees equal to the arc length out of the entire circumference or perimeter of the circle. So we know that the angle is 100 degrees, specifically for ADC, and then we know that the entire thing is of course going to be 360 degrees. And so like I said, we want to set that ratio equal to the ratio of the arc length, which is 5 pi, to the entire circumference, which once again, we don't know the entire circumference, but we can just call it C, and then we can solve for it. And once we know the entire circumference, we can of course subtract this value to get the missing value of arc ABC. So once we have this, first let's simplify this left side by canceling out a 0, so we now have 10 over 36. We can actually simplify that one more time by dividing by 2 to get it to just be 5 over 18. So ultimately we have 5 over 18 because once again, remember ratios are just about what is like the percentage difference between the top and the bottom. So it doesn't matter if we simplify it as long as it has the same ratio or the same proportion between the two numbers, that is fine. So we have 5 over 18 equals 5 pi over c. So we'll go ahead and cross multiply. 5 times c is 5c, and then we're going to say that equals 5 times 18 pi, or 18 by 5 pi, doesn't matter which way we write it. Okay, so now we can see that we can divide both sides by 5, and we have the circumference is 18 pi. So if the circumference is 18 pi and ADC is 5 pi, then really quick, what do you think the length of ABC is going to be? Well, it's just going to be the circumference, 18 pi, minus ADC, which is 5 pi. So if we have 18 of something and we subtract 5 of something, we're left with 13 of something, and so the answer is going to be B, 13 pi.